I'm gonna be ensure that all of the components can be placed efficiently on such on as little area as possible. And my original idea was to kind of put the motor drivers close together, or actually my second original idea. My first idea was to place one motor, but I realized that they have so many shared things that routing signals would be very inefficient. So I placed them close together like this. As I placed all the area and tried to kind of arrange the parts that I've pre-assembled here such that they would fit, I really good place to fit that translate the input 48 volts to 12 volts and to 5 volts, and then we have two 3.3 volts regulators to put this. So yeah, I can put it there, but then I would have to make the board longer, but then I have to route the power underneath or over any kind of like digital signals, and I don't want to do that. Primarily, I don't want to route the motor power from one side of the board to the other side of the board. So I think that the best place for this regulator or this power block would be between the two drives, because then we have the motive power that goes directly to the that just has to go from here and to the MOSFETs here. All of this high voltage portion of the PCB right about here. So we don't need to have any high voltage between and the digital logic part. Logic part as quiet as possible also, because we're not going to have the interferences coming from the main power rails, which are going to fluctuate because there is going to be very varied load on the power rails. So the voltage will vary, and any noise, we don't want to couple any of that noise into our digital parts. So it would be good to place 3.3 volts and 5 volts regulators coming out somewhere here, and connected directly to some internal layers and internal tracks that parts of the rest of the board here. So what I have to do then is essentially just move the motor a little bit farther apart, and then rearrange this power block so that I have and make it maybe a little bit longer along the horizontal direction. When it comes to the costs of the PCB, depending on the size, typically the cost is calculated as an area cost. So it doesn't really matter what the size of the PCB is, but on this PCB I want to have in this case the top side, and connectors that are relevant to the other motor on the bottom side. And any of the sort of communication interfaces like the EtherCAT opposite side here, and the USB. So let's get started here. Let's see what we can do. Let's see if we can achieve a better result here that can more easily connect to the power stages. So essentially, it's just I'm gonna move these parts out a little bit. This is the circuits. Let's see. This is the encoder interface, and this is the other encoder interface. And it looks to me like I also moved the surrounding frame here. see. Can I select that? Yeah. I think I'm gonna just delete that because for now it doesn't really matter. I have plenty of components here intersecting with the it's supposed to be just for the, but I had to put it that way because I wanted to try to fit this into 10 centimeters on this side, but now I think that that would be a bad idea. I don't want to sacrifice. I can route the power directly to the motors. That's just not worth it. I'm going to make the PCB a little bit bigger than 10 centimeters. Easily make sure that things can be routed properly. Let's place it there for now, and then also do this. Remove this one there, and then I just have to make little resistors and capacitors that I'm going to try to separate them this time because now that I'm making the board bigger anyway, I could make sure that one of these blocks angle. So let's see. This a little bit more. And now the idea is directly here. So the power connector will go, let's see, I'm going to separate this part as well. This is the sensing part. This is the supply sensing. One of the annoying things with KiCad when it comes to text is that the text gets actually rotated. So if you rotate your block, you have to rotate the text separately. It would be nice if there was an option to make sure that this text behaves exactly the same way like the designators, that you cannot rotate it upside down. Okay, I think this one belongs, let's see if this one belongs to the 5 volt. No, okay. This one is that actually correct? Sometimes the cursor is pointing at the wrong part. This seems to be correct. Yes. So this goes, except that this one is not supposed to be there even. This one is supposed to be, yeah, let's see actually, because we're going to be moving this regulator somewhere here anyway. So I'm going to just separate the 3.3 volts and the 5 volts regulators. And then I can place that resistor where it should be. Okay. Let's see. I wonder if I messed up this recommended layout now. This goes there. Okay. Let's see if I can place this as one block, so that it's all sort of the same width as the connector. Yeah, this is the output capacitor, so it can go there, and this is the diode that belongs to the regulator, so it has to go there. And then obviously this inductor. I'm going to delete that little line as well, and the power text. This is output as well, part of the output circuitry. And then I can maybe move this, let's see. This one just goes across there, but I don't want to waste the space that is here. Let's see, so this goes there, this goes there. This one's rather big, so I can't fit all of the parts on this small area. So I have to do something like this. What is this? Okay, yeah, I can actually maybe fit the resistor there. Right. I just had another idea here. So the not that one, but the break, this one. This one would be good to have also on this side of the PCB because it tightly connects to the main power. What is this? Okay, that's for the encoder interface. And this one is for the overcurrent adjustment. So these two actually should be somewhere here. I'm gonna place them there for now. Maybe I can place this capacitor somewhere there. Let's see here. Okay, so this is the output, yeah. And then this has to connect, yeah. That's pretty good because then we can just place one big area of copper here that covers everything. So that's a good arrangement. And also maybe I should make the 12-volt connector a vertical connector so that I can place it in the middle of the PCB. That's one idea to deal with that connector. And then I can minimize the width of the area that's required between these two. Because I don't think it makes any sense to place anything else there. Don't fit the regulator into this the area that is about this wide, then I will have a lot of wasted space. And this is the brake circuit. So then all of this has to go somewhere behind somewhere behind this diode. Let's see. Would that make any sense? This goes, okay, so this connects there. Could make sense. So then I'll have to move this. Let's see. Okay, so this goes. So one of the things about this break resistor is that this has to be able to lead a lot of current. So any trace that goes to the break resistor output is going to have to be a thick trace. So if I place it too close to the motor outputs, I may not have enough space to route a thick trace. So I'm thinking that maybe I should actually place this diode. Maybe I should rotate this diode actually somehow like this. Or route this VMOT to the brake resistor using an internal trace. Okay, what is this? Let's see. This goes to VMOT, and this goes to the other end there. Let's see, where does this go? This is going to be the gate. Okay. This could go there actually. And there is a resistor that, oh, this looks actually perfect. Could actually have the resistor there, and this connects directly to the VMOT in, then goes to the diode, then goes to the transistor, and there's something else here as well that I forgot. Yeah. Place them for now there. And then from the transistor we have VMOT. So this is probably the most problematic of all the traces here. So this will have to go on an internal layer. Then we have the transistor goes to this resistor, and this goes to the gate of the MOSFET, ground, and let's see. So we're going to have a larger area here that is connected with bias to the ground, because this is going to be a high current path. And the other end of the brake resistor goes to VMOT. Maybe I can route the VMOT actually around here. Yeah, this is a bit better. So this will be a large area that just goes like this, and then VMOT can go slightly around, maybe, and on internal layer. So I could essentially just have bias going to internal layer, and also on the top layer I can just route this directly here as well. Then the capacitor can go. They're so bulky, those large round capacitors. There's really no place to put it where it doesn't stick out or waste space. Let's see. Maybe I can put it here. Although it has to be, yeah. So we have the current sense resistor, and then we have the input capacitors there. Right. It would be nice to do something like this. This is like playing Tetris. Yeah, PCB layout is like playing Tetris. I think that's a good comparison. Okay. So I have this one that needs to be connected like that. And this one goes to the input there. So maybe I can move this here. The clock resistor. Let's see, would this even fit there if I were to place it like this? Look at this. This would be so perfect. This would be absolutely perfect. Problem is that this capacitor needs to connect to that pin using a thick trace. Yeah. Okay, I think I can place it there. It will have to stick out a little bit, but it's not the PCB edge, so it doesn't really matter. It's just not as pretty as if this would just fit nicely in there. It's so perfect. Okay. Anyway, because I also have the inductor that I have to place somewhere close to the diode there, it's probably a good idea to just arrange it this way. So the inductor goes to the output capacitor, which is this one. Yeah, this is nice, I think. Maybe I can make my Tetris blocks fit after all. Okay, so I'm gonna leave a little bit of space there because this is gonna be a ground, so I'm gonna have bias here and then connect to this ground as well, which is also perfect. And I can also have place for the designators there. This capacitor can be moved a little bit out like that. I only have this inductor. Yeah. And this is ground, I think, yes. Okay. There was some capacitor there as well, that this one, where is that one? That one is right there, okay. And then maybe I can just fit the 3.3 volts and 5 volts regulators somewhere here. The input capacitor to the 5 volt regulator. And this 12 volt output, which goes to the fuse. Oh, I could place the fuse here. This is perfect place for the fuse. Let's see. Check. This goes there. This goes. Yeah. Where is this fuse? There. Okay. Output is there, then there. And then through the current sense resistor there. I'm just thinking that if I can move this, then I can have this thick copper trace that goes around. It could go through this direction and that direction as well. Let's see what this is. This is used for yeah. So this connects to ground from that pin, which means yeah, there's no better place for this one. And then I have this connector. So if I make this connector a vertical connector, it's going to take around that much space. So I have to think about that. And where to put it. And this is the VMOT voltage sensing. This can essentially go closer to the main controller. And then this part we can just move in between here. Yeah. The brake resistor out. I'm gonna move. And then this one. It would be nice to place them as close as possible. The only thing that I need to consider here is that if I place the components too close to the connectors, then soldering those components, if I ever need to replace a component, would be hard without ruining the connector. So that's one of the side effects of placing this is going to be between two connectors as well. So it's gonna be tricky. I'm gonna arrange this properly a bit later. Here we can have a large area there. Then we have the VMod, and the VMod is, as always, hard to select. Could select, yeah. So this output is gonna go through by and just about this area. That's perfect. I think it's a good idea to actually move the connectors and move the parts a little bit farther away from the connectors. Let's do like this. There we go. So let's see here. What would be a good courtyard for this connector? We've got 1.8, 1.7 millimeters. That'll have to do for now. Actually, yeah, let's just move it a little bit more. Like that. So this is looking good. I can probably also optimize the placement of these components. Maybe move the designators above and below the resistors there, so I can have a little bit more space there. But let's see what width is going to be now. So I'm going to have to reserve a little bit of space for the mounting holes, which, by the way, I haven't added to the schematic yet. Oh, come on. Deselect that. I don't want, there we go, perfect. Okay. So the mounting holes will go there. Let's actually add the mounting holes as well, so that we have them on the schematic. I'm going to place the mounting holes there. I'm going to add 4 mounting holes to begin with. I'm probably going to have to have more mounting holes because this is a large board. Let's see, mount hole. I have a component in my library that is called mount hole, and it has a footprint attached to it. I don't connect mount holes to ground. I think that's important because if they're connected to ground, there is no way to have full control of the grounding. So I don't connect them to ground. I can connect them to a separate ground, that would be the shielding ground, which is then externally connected to the main ground. All right, and yeah, this will have to do. This can go actually somewhere. Let's see. Let's place them there. Let's place them in the cave. Cave. Okay. Update PCB from schematic. All right. A 3.5 millimeter hole and a 7 millimeter diameter on the outside. Let's see how much it is. 3.3. That'll do. Has to be more than 3. And 6.8. Yeah, that's gonna be fine. Although I'll update the footprint to, let's see. I'm gonna make the ring around the button, the hole, a bit bigger. 3.2, and let's make this. Let's make this 3.3 and 7 millimeters on the outside, because you can have screws that have a wider head, which means that there needs to be enough space. So this will go, and also, where's the question mark? MT1. That is supposed to be MT4. That's weird. Unfortunately, I have edited out from KiCad the ability to modify any fields here, because I wanted to force myself to modify the fields in the library, so as not to follow the default workflow in KiCad. So now I can change the field. Maybe I can just show it. Maybe I can change it like this. I can actually change it like this, yes. Let's see. Was this a bug or something else? Yeah, it worked fine this time. Okay. And I think I can hide this designator in the footprint editor. Let's see. Invisible. That's good. And also on the Fab layer, let's see, what layer is this on? This is Fab layer, right. We can do M3. Let's also add a Fab Layer Cross in the middle. I'd like this actually. So we have M3, and let's align this one as well. And then I'll just draw a cross in the middle on the Fab layer. No, damn it. There we go. On the Fab layer, and this will go like this. Let's see, so where's my position there? So like that, and maybe a circle. I don't think I have anything on the Fab layer actually besides the text and the cross right now. Could I hide this? Yes. Great. Okay, so I have something on the Fab layer, I think. Is this? No, this is Courtyard. What is this then? User. Yeah, so we need to make sure we have a circle on the Fab layer as well. Let's see. Can go like this. This is going to produce nice hole drawings, and this one is on. This one is silk screen, and this is the Fab layer. Yeah, so they're different. They're on different layers. There we go. And go back and update this footprint. And this didn't hide my designators. Invisible. I think that is a bug. That definitely needs fixing. If I update the footprint, or actually it's not a bug if you think about it as the way KiCad views their workflow. So in their minds, you're supposed to be like editing footprints, I think, on the PCB layout, which is kind of like weird for me. I think that doesn't make any sense. Just like assigning, like they've added in the version 5, they've added this this stupid table there. Let's see. That is supposed to let you modify your fields, and this is just another step in the wrong direction, because you shouldn't be, like when you modify a field here, you're actually modifying the field on the schematic, whereas in order to make anything work in a half reliable way, all the fields should be modified in the library, so that you can then instantiate your components and update them. All of your instances have the same fields. So anything like this is just totally useless. This is even useless in the sense that if I wanted to see the number of unique components, I can't do it here. I have to export the BOM. column here that specifies the component number, or some kind of like statistics box that gives you the number of unique components. Number of unique components, number of through-hole parts. Although that can be hard. Like, how do you identify? You should then flag the through-hole part manually, because if you just look at whether the part has any holes in the footprint, then you can easily have wrong positives if you have parts that have bias, for example, in the ground pad. Okay, so this is just KiCad's way of doing it. So I think that the correct behavior here, or the actually useful behavior, would be that when I update this footprint from the library, it has to update all of the visibility settings as well, and not just the footprint itself. Okay, so and then this side will also be to the motor driver, like that. Thirteen and a half. So 14 centimeters, or 130 millimeters. I think we can probably fit it into 130 millimeters, or 13 centimeters. That will be smaller. Let's see if that is okay. Let's see what this looks like in 3D. Okay. Complaining about the board outline. So this 3D model is wrong, and I have a lot of components that I've created myself, which I don't have any 3D models for. But in terms of the connectors, probably I can just move these ones closer. Maybe that would be enough. I don't want to move the connectors closer together though. I think this is just about the minimum distance between them. So I can try to move these two. Let's see how wide it is. Yeah, almost perfect. 1 millimeter. Can we do 1 millimeter? Can we gain 1 millimeter somewhere? Can move this one a little bit down, like that, which means we can also move this one. Like, I want to make sure that the silk screen is visible, and then I can place this one there. Actually, this could be rotated. And like, why not? This could be rotated actually. I'll have to update the footprint though. But let's assume that we update that footprint. So let's just keep it like that for now. And that would mean that we can move this footprint. Oh, damn it. Let's see. That means we move this footprint somewhere here. And that already gives us 1 millimeter. even that much. I think that would give us 1 millimeter. Let's see. Yeah. Okay, that'll have to do. Like, I don't have to place this perfectly right now because I'm still probably gonna move some of the parts, and I have to align them properly. Like, I have to select all of them and just do align to the left, so at least get that kind of alignment. But yeah, there is that this could actually work pretty nicely. So we have the high voltage part, then we have the switching that spans this part of the PCB, and all of the inductors go also to the place of the PCB where we have the most interference. Voltage regulators come out in the middle, which is also perfect. And then here I will place control circuitry that will kind of span this area, like a C there, and in the middle here I'll place the microprocessor. And then on the other side I'll place all of the interfaces, such as CAN and USB and EtherCAT. So this is encouraging. This is nice. I think this could work very well. Alright, that's it for this video. Thanks for watching.